Good morning, student. Today's lecture is based on gas lift. So gas lift system is used as an artificial lifting system, and this technique is basically to increase productivity rate. When wellbore pressure goes down and reservoir fluid is not moving inside wellbore and is not moving towards the surface, so that time you need some artificial lifting mechanism. So using gas injection technique, you increase the productivity. Okay. In previous lectures, you have seen sucker rod pump, ESP. Okay. In ESP and PCP also there. In SRP, you have seen it is a slow speed pump, and when wellbore pressure is very low and you are getting, like say 5 barrel or 10 barrel, a very low amount of fluid flow is there. So in that case you can use SRP systems. ESP, it is little bit higher flow rate pump, let's say 5,000 barrel per day you can produce, and RPM of ESP will be like 3500 RPM. SRP stroke number of strokes per minute will be like 5 or 10 or 20. And PCP, progressive cavity pump, it is high viscosity pump. When viscosity of oil is very high, so that time you are using PCP. But in gas lift system, you are injecting gas, so it is independent of actually viscosity or amount of gas or amount of sand in the coming through the wellbore with oil, water, gas. If you have certain higher amount of gas, let's say high gas liquid ratio, gas to liquid GLR, so in that case actually you can use gas lift system. So gas lift system, you are injecting gas, so if you are getting some amount of gas from wellbore, it is still fine. But if you have gas and you are pumping using SRP or ESP, then there will be difficulty. Okay. And gas lift system is very much versatile actually, because you can pump 50 barrel to 2000 barrel with single gas lift mandrel or gas lift valve mechanism will be there. Using that one, you can produce different amount of fluid throughout their wellbore life. In many cases, production engineers will be putting gas lift mandrel or gas lift valve at the beginning stage, so that later stage when production will be depleting or reservoir pressure will be going down, so that time you don't have to put the gas lift mandrel or gas lift system separately, because if you want to put gas lift mandrel later stage, so you have to retrieve the tubing and you have to fix it. That will be a difficult job. So at the beginning stage they will put gas lift mandrel, especially in offshore wellbore they will be putting this one, so that later stage production down, so you get more production using gas lift system. And gas lift system will have like this: a wellbore is here, okay, and case it, cement it, then you have one tubing, you put one packer. Packer will not allow wellbore fluid to pass through this annular area. This is annular area, okay, this is annular area, and this is packer, okay, and this is tubing, you already know all this, and this is casing and cementing, casing, cemented. And why cementation is done, you have to you can go through it through Google search or previous lecture. Actually I already explained why cementing must be there, so please go through those basic things. And casing should have some perforations in oil or gas zone, okay, so the perforations we make like this sometimes, so different notations will be there. So this is reservoir, and oil or gas will be entering, and water also can be there, sand also can be there. If you have proper sand control mechanism, sand amount of sand will be lower. In some cases oil, water in and oil, when you are producing oil and oil, so water also will come, because the reservoir may contain certain amount of oil, and because of different dry mechanism, oil, water also coming into your wellbore. So if liquid in the form of oil or water is coming into wellbore, you have to pump it. If gas is coming, still you have to pump actually, you are going to stop the gas coming in, okay. Then on the surface you have wellhead, okay, wellhead, IROWH means wellhead, okay. Then wellhead you are going to separate a system, Okay. Then you are sending to transportation mechanism, wagon transport, or by shipping transport or pipeline transport, you are transporting to the refineries. And when from separator you are getting gas also. Okay. So in gas injection system, what you do, whatever gas you are getting, so the gas actually you can inject, okay, through this annular area, and you will have certain mechanism called gas lift mandrel or gas lift valve system. Okay. So you will have gas lift valve. Okay. So using gas lift valve, you inject small bubbles. Okay. So the bubble will be enhancing your productivity. So whenever you are injecting gas from surface, you need one compression system. So one compressor must be there. So compressor must be there. Okay. And how, from where are you getting the gas? After separation you are getting the gas, so same gas you can inject and you can produce, and the excess gas after production, whatever excess gas you are getting, so that gas you can send to your customer. Okay. And whenever you are compressing a gas and you have multiple wellbore, so you will have one manifold where you can distribute the gas to different wellbore. So maybe this will be wellbore 1, maybe there will be another wellbore, wellbore 2, then may another will be wellbore 3. So different wellbores will be there, and different wellbore may have different gas injection criteria. Say wellbore 1 needs 250 psi pressure, wellbore 2 may be 500 psi pressure. So different wellbore may be requiring different amount of pressure. So your manifold will be controlling the pressure amount, and it will be distributing gas into different wellbore. So one compression system will have, one separator system will have maybe. Okay. From there compressed gas you are sending to different wellbore, and you are getting a higher productivity. And this whole lecture basically I have taken from the book Technology for Artificial Lifting Method, and the author is Kermit Brown, volume 2A. Okay, it is there in chapter 3, I think, volume 2A, I guess. Just you can verify that one. Volume is written there, volume is 2A. Okay. Okay. So if you see a gas lift system, so you have two part. One part is subsurface part, which is under the surface, and you have gas lift mandrel, gas lift valve mechanism, and on the surface you have compression system and separator systems. How does it work? You see this whole picture. You have one compressor system here, compressor. You have one compressor, and from compressor the gas will go to your high pressure gas distribution room. So here you are distributing and you are sending to one wellbore here. Okay. And maybe it will go to another wellbore, it will go to another wellbore, so multiple wellbore it can go. And you have one big compression system, so that compressed gas you can send to different wellbores. Okay. So the gas will be entering to this tubing. Okay, this is your casing actually. Okay, casing and cemented, and there will be perforations. Okay, this is packer. And liquid or gas or oil will be entering through this. Okay, our main target is to produce oil, not water or not sand. So whenever a completion engineer will be working, they will try to complete such a way that you get more oil, not water or sand. How to avoid this oil and water? So water is heavier, so it will be forming, like say in same reservoir you have oil and water both. So water will be forming lower layer, oil will be forming upper layer, because oil will be lesser density. Okay, now you perforate only this oil zone area, so that water will be less. But in certain cases, oil and water both will be coming together. So in that case, you have to handle on the surface. If you are producing more water, water is not giving you money. Rather, you have to separate on the surface, so that will be costing you money actually. So your money will be wasted if you are producing more water. So you have to avoid, because you have to dispose it, you have to separate it. So there are several difficulties will be coming. So better avoid water to produce. If you are getting oil, it's okay, life is beautiful. If you are getting gas, it's still fine, life is beautiful, because gas will give you money. Oil you are getting, because you are injecting gas, so same gas will be going up to the surface again. Okay, so oil and gas you are getting. Okay, now this will go to this area, oil gas metering station, from metering station to treatment area. Okay. So, you separate oil, water, gas, you treat the gas, then again the natural gas, you send oil to export line and natural gas will come to this. Okay. So, some gas you can sell, some gas you again you have to inject. So, this way the whole cycle will go on. Okay. And normally you are not injecting air, because if you are mixing air, means it is having oxygen. Nitrogen if you mix, there is no issue actually, because nitrogen is not harmful, it is inactive gas, inert gas. If you are putting oxygen, then what will happen, oxygen will mix with hydrocarbon or natural gas, then it will be creating a combustible mixture. So, that will be a very dangerous thing actually. If it gets small fire source, all things will get busted. So, avoid oxygen actually. Okay. Now, there are two type of gas lift system, one is called intermittent system, another is called continuous system. Continuous system is if you have higher amount of liquid you are getting and reservoir pressure is also higher, in that case you inject continuously gas. Okay. So, continuous gas will give continuous oil and oil production. So, for higher productivity you can use continuous gas system, but intermittent flow when do you use? Let us say some de-liquefaction gas well, you have gas well, right, like this, and it is a gas well. Okay. In gas well, so liquid held up will be there. Why liquid held up will be there? In gas well you try to create mist flow. Okay. You try to create mist flow, so that whatever liquid is there, it will create very small particle, it will move with the gas. So, there will be no liquid accumulation at the bottom. But if your reservoir pressure depletes and flow rate decreases, so if flow rate decreases, mist will not be formed, rather it will create small bubbles. So, slowly bubbles will be sliding down. Okay. When sliding down, and it is getting accumulated here, okay, at the bottom. When it is getting accumulated here, what will happen? If I have reservoir pressure PR and PWF, so flowing pressure will go down. So, it will not be pushing fluid up, okay, because already liquid is creating some hydrostatic pressure. So, because of the hydrostatic pressure, entry into wellbore, oil or gas or water will not be there. Okay. So, in that case what you have to do, you have to remove this water part. Okay. If you are not removing, then production will be stopped. So, in the how to remove it, small amount of water getting deposited, let us say 5 barrel per day or 10 barrel per day, what you do? So, in that case you put one plunger lift system. Plunger system is one catcher will be here, okay, and you put one plunger here. Okay. So, when liquid will be build up, liquid column will be building up, after certain amount of column build up over the plunger, okay, that time you inject gas from the bottom of the plunger. Okay. So, you have plunger here, okay, and you are allowing liquid to build up here. Okay. Liquid will be entering through certain holes. Okay. Now, you inject very high pressure gas here. So, because of very high pressure, the plunger will move up. When plunger is moving up, it will take whole liquid column also with it, and it will be delivering the liquid. Okay. So, in that way you remove liquid from the wellbore. Okay. So, gas is helping to move the plunger up. Okay. And intermittently you are doing, continuously you are not moving the plunger up and down, maybe one day two times, 3 times you are moving the plunger up, creating a high pressure high. Okay. You create high pressure, move the plunger up, and you are delivering the fluid, whatever liquid is collected, that will be moving out of the wellbore. So, that is called intermittent flow gas lift. But in continuous gas lift, there is no such type of plunger which plunger is moving and it is removing liquid. Rather, in gas lift system, continuously you are injecting gas, you are getting production. Okay. Gas lift valve. When you are injecting gas, okay, when you are injecting gas will be going through this, and this is called valve actually. So, what does it do? Through this valve, actually small nozzle you can assume, you create one small nozzle and you create small bubble. Okay. So, when you are creating small bubble, so let us say this column is filled with liquid, okay, liquid, let us say water, and create small bubble. So, what will happen? The bubble will take certain space. When it is taking space, so for example, this column H rho g pressure, alright. Now because you injected bubbles, so bubbles means it took some space, so total actual liquid volume will be lower. So in that same height, actual liquid volume will be lower. That means average density is down, okay. Because average density down, so rho 1, okay. So initially with completely liquid, P2 is with gas bubbles. So because of gas bubble, it will be porous column actually, and total liquid weight will be reduced. When liquid weight is reduced, if there is, this was PWF flowing pressure, this is P reservoir pressure. So reservoir pressure you are not changing because of gas injection, you are changing this pressure, okay. So difference between this PWF and PR is high now. So more liquid will be entering into Wellbore. So more liquid entering means more production rate will be there. But if you do not inject gas, that whole liquid column weight will be very high pressure and reservoir pressure. Reservoir pressure and that flowing pressure will be almost equal. So in that case, fluid will not be entering into your Wellbore. So you remove the column fluid as much as possible, more liquid will come from the reservoir, okay. So that this way your gas bubbles help, and it will be bubbly flow, okay, your bubble flow, okay. So if you remember the multiphase flow lecture, I told that bubble flow will be helping. If you are getting mist flow, very small particle, it will not help actually. Mist flow means you have to inject very high amount of gas from a surface, okay. So that is not possible. And if you inject very lower amount of gas also, small bubble will be created, but that will not help much. So you have to inject optimal amount of gas so that you can get more production rate. So it should not be wavy flow, not stratified flow, it should be bubbly flow or Taylor bubble flow, okay. And where to inject the gas? So whenever you are injecting gas from the surface, first you inject on the top valve. This is one valve actually. You create small bubbles, okay. When bubbles are moving up, and if you see this, if I say 1, this, if I say this section is 2, you see one portion pressure will be higher because H rho g, 2 portion H will be lower, H rho g, okay, because height, column height is lower in 2, in 1.1 in this picture, column height is more. So column height more means more pressure. So bubbles will be getting compressed, but when you go up to the column, the bubble will be getting expanding because the pressure is lower, okay. So when bubbles are moving from Wellbore from bottom to top, the bubble size will be enlarging actually, okay. So it will be dispersing more fluid. So from bottom side, your average density will be higher, top side average density will be lower, okay. Now when you are injecting gas, first inject the top valve, create bubble, then your column weight will be reduced. Then next you do, next valve you inject gas, again further column reduce, again further lower, you inject gas, gradually you reduce column hydrostatic pressure, it will be giving more production rate. The lowest valve is not always the operating valve, okay. Operating valve may be this one or maybe some other valve, okay. In this case 3 valve, I am just showing operating valve is bottom one, but it may not be true every time, okay. The engineers who are working in the field, they will decide which one to keep open, and based on their requirement they can change operating valve, maybe top one, bottom one, like this. Flexibility, one gas lift system can be produced 1000 barrel per day to 50 barrel per day, okay. So any amount of gas you can control. If you inject gas injection rate, if you can control, and if you can control the valve operating point, then actually you can change the production rate of oil, okay. So but other artificial lifting system, that they may not have so much flexibility. Gas lift is having this much of flexibility, that's why it is very much commonly used in almost all oil and gas industries. SRP is the most common one, but next one is the gas lift system, because it is giving higher productivity rate. SRP is very common for lower flow rate, but it is having lower productivity rate. The barrel per day is very low, but gas lift system barrel per day can be very high. Okay, So here some theories you should remember. So gas lip mandrel. So mandrel is that like you are inserting tubing. When installing tubing, actually you create one pocket, it's called gas lip mandrel pocket. There you can install your valves. So valve can be pre-installed or wear line installed. Wear line installed means later stage using wear line you can insert the gas lip valve. But many cases people will be inserting gas lip valve at the beginning stage. So it will contain this gas lip mandrel, this one, or gas lip mandrel pocket, sometimes they say. It will have gas lip valve actually. Okay, later I will explain how this works, whole system. This is gas lip valve, and this will have check valve, seat, and many things I will explain later. Because gas lip mandrel installed in the tubing string, two primary types, conventional type and side pocket type. Conventional type means initially fix everything together and you insert the tubing. But side pocket mandrel designed to permit gas lip valve and other download component to be installed with air lines, wire lines. There are different types of valves available. Later I will explain in details, but all the types we cannot discuss in this lecture because only 1 week lecture I have set for this one. There are several types. One is casing pressure operated valve or pressure valve. These are classified as unbalanced bellow valve or balanced pressure valve. Unbalanced valve means it will be controlled by tubing pressure as well as casing pressure. But when balanced pressure valve we are saying, so tubing pressure will not be affecting the flow rate or controlling the valve. Throttling pressure valve, another option is there. Fluid operated valve is there. Combination valves are there. So different types of valves are there. Okay, because of limitation we will not discuss everything in this course, but a few things we will discuss in this course. Okay, so here I have selected one example. This example is given in book Kermit Brown actually, to understand how the gas lip system is working. See the example. Let us say one wellbore is here, depth 5000 feet, okay, and tubing flowing pressure is 100 psi. Frictional resistance F equals 0 they are assuming. So there will be no fluid friction. FLV square by 2 GD, FLV square by 2 GD del P equals 0. They are saying because F is 0. Okay, they are asking PWF, PWH, wellhead pressure requirement 100 psi, but flowing pressure you have to find. Okay, for this wellbore. So initially they are asking, assume 100% salt water is there, density given 1.07. So and gradient also given 0.465. So so PWF equals 100 bar wellhead pressure, 100 psi wellbore pressure, and your gradient is 0.465 into 5000 height. So total flowing pressure should be 2425. This is 5. Okay, 2425 psi. Okay. Now, if I consider B, 100% API oil, gamma oil is given 0.1815, gradient also given. So, what PWF for A, PWF B, for B we are getting 100 wellhead pressure plus you can see 0.345 into 5000. Okay. So, it is giving 1870 psi pressure, flowing pressure. So, same wellbore, if you are pumping water, so your flowing pressure requirement is 2425. So, that means PR must be more than PWF, then fluid will be flowing from wellbore, from reservoir to the wellbore. So, in case A, you can see PR must be 2425 or more, not PR must be 2524 or more, and PWF flowing pressure should be 2425. We are assuming there is no friction factor, fluid friction, and if there is fluid friction, then again reservoir pressure must be much higher, because you have to include that one also. PWF for case C. In C 100% oil you are assuming, but there is solution gas. Okay, some gas is there in the oil, so gradient is reduced to 0.25. Okay, so in that case PWF should be 100 plus 0.25 into 5000. So it is becoming 1350 psi. So if there is some amount of gas, then actually it is giving low flowing pressure. So it will be it is helping. And another case D. Case D is saying, like say continuous gas lift system you have applied, okay, and because of gas lift system your gas that fluid column gradient, pressure gradient is changed to 0.1 psi. So 100 plus 0.1 then into 5000. So it is becoming 600. Okay, so you can see how this flowing pressure is changing for the same reservoir pressure. Let's say reservoir pressure say 3000, okay, 3000 psi. So in first case, in case 1, you see 3000 minus 2425 around 500 around 500 psi pressure difference. So flow rate will be lower. But if you see case D, 3000 minus 600, 200 pressure difference. So flow rate will be very high. Okay, so your productivity will be increasing. So you can see how this gas lift system is working. If you have solution gas, it is helping. If you have injection gas, continuous gas system, then there also you are getting more productivity. Okay, so I hope this clears how gas lift system is helping in production.